Good evening, everyone, and good morning to many others. Welcome to the last online session of TDK Ventures Energy Week 2022, where we're discussing a variety of topics related to energy transformation, electrification, and beyond. This event is hosted by us at TDK Ventures, which is the corporate venture capital arm of Japanese electronics giant TDK Corporation. My name is Anil Achyuta, and I'm an investment director at TDK Ventures, and I lead our investments in energy and health tech. And so far, I'm an investor in 11 outstanding deep technology companies. I will be moderating our panel session today with our esteemed guests, Emily Baudouin, Stephen Vassiloudis, Haisha Deng, and Tem Tumurbat. Welcome. Emily is the founder and CEO of Pure Lithium Corporation, a company taking a systems level approach, utilizing electrochemistry to enable lithium metal battery technology from the ground to the battery. Emily has the coolest background. She was a PI or a principal investigator from Argonne National Laboratory before, and also worked as a research analyst at a quant hedge fund in New York. How cool is that? Welcome, Emily.
Thank you.
Next, we have Stephen Vassiloudis. Stephen is the founder and CEO of Novolith Technologies. Novolith focuses on lithium extraction and refining using a novel CO2 capture and conversion technology that leads to battery-grade, environmentally friendly lithium chemicals with a whole new lens of sustainability. Stephen comes to us from Sydney, Australia, and he is missing out on the fun T20 Cricket World Cup right now for Energy Week. Thank you, Stephen, for your time.
Thanks for having me.
Next, we have Dr. Haisha Deng. She's the VP of Cathode at Ascend Elements, a lithium-ion recycling and advanced materials company. Haisha has authored over 30 publications, has several patents. She received the 47th R&D 100 awards for the accomplishment in lithium-ion cathode materials and recognized as one of the 40 top women leaders in energy storage by Energy Storage Report last year. Haisha, welcome.
Thank you, Anil. Glad to be here.
Next, we have Tem Tumurbat. He's the co-founder and managing partner of Nomadic Venture Partners, an early-stage climate tech venture capital firm focusing on decarbonizing mining, manufacturing, and transportation sectors. Tem has a rich history in the mining sector, and we'll be talking about a lot of his background in the early part of this conversation. Panelists, welcome again. This session will last about 45 minutes, and we will reserve a few moments for audience questions. Without further ado, let's dive right in. I want to call an icebreaker here. I'd like to get the panelists' view on the effect of geopolitics, globalization, and localization to new innovations in the mining and recycling sector. Who wants to go first? It's a free flow conversation.
I'll go first.
All right.
I think today more than ever, vertical integration is hugely important. If we're going to fight climate change, we need to think about batteries in different geographic locations using materials there that make sense. So imagine a battery in India that uses materials that India can source, that is a little easier to design because you don't have to deal with 0 degrees in the cold. And in these situations, if you rethink supply chains and availability, we really do have a chance to make a big dent in climate change. If we keep doing things as we do now, there's no hope.
Thank you, Emily.
Yeah, thanks, Emily. I can add a little bit as well. So I think we are all of geography. So you won't say we're born equal, but actually we don't entitled to get the equal access to all the resources. And the lithium-ion battery is not an exception for this. So let's look at how unbalanced of the lithium-ion battery industry between Eastern and the Western country. Up to 2021, almost 90% of precursors of NMC are produced in Asia. The top 10 battery companies are in Asia. Still is currently produced in China. So I think the geography, politics play a big role on this kind of thing. And the Chinese government has started the funding 10 years ago. And that's maybe one of the main reasons to have the maturity, the fully development of my battery supply chain there. But I think globalization is also very important for the success of lithium-ion battery in the last 30 years. As we say, knowledge has no boundary. Tesla also opened their RP sources for electric vehicle. That also bring a big booming for the electric industry. So I think globalization is also very important. And Emily said that we get the resources from everywhere, produced in another place. So I think, yes, globalization and geopolitics play big roles in the development of lithium-ion battery industry.
Thank you, Harsha. Stephen?
No, I definitely agree. And I think at the moment, if you look at EVs in general and supply chain from, say, mine to EV, all roads lead to China and then back out to the rest of the world. I think one thing that COVID has taught us is that having that reliance on one particular place or geography for supply of whatever material or whatever equipment you need may not be the best thing moving forward. And so having countries like Australia, the US, and continents like Europe being able to be a bit more, I guess, self-sufficient may not be a bad thing moving forward.
I saw a recent article that said we are really not in the energy transition, we are in the metals transition. What are our panelists' thoughts here?
I 100% agree. We're in a metals transition. We need these metals to be successful in transitioning from fossil fuels. And if we don't get them, then the game is over. So it's just a really simple way to put it. And I think it's important, we were talking earlier, that we need to educate people about mining and get around the aversion to it, because we're not going to make forward progress if everyone is just fighting against miners. And let's just remember that everything we touch or grow, just to quote Robert Friedland, it's either mined or it's grown. That's it. There's no other option.
It reminded me the chemistry in the lithium-ion batteries and also recycling. So lithium come from the mines and go to lithium-ion batteries back and forth and then come back to recycling. So it's just a different life for different metals. I totally agree. It's this issue in a different perspective.
Yeah, and it's not just lithium ion, right? It's rare earths, because the motors require different kinds of neodymium magnets and dysprosium, and maybe even copper. If we want to electrify everything, we need a lot more copper. And where does copper come from, right? And there's many more. So maybe Stephen, can you comment on other metals? Because it seems like nickel, cobalt, manganese, copper, dysprosium, all of these interesting metals are such a vital part of this value chain.
Definitely. Well, if you look at the electric future, you have everything from, I guess, the battery and working your way out from the battery. So you obviously have lithium, nickel, cobalt, depending on your cathode chemistries, as well as on the anode side with graphite, silica, etc. And most of those things come from natural resources, either ground, or if you're looking at, say, brines as a source of lithium, the aquifers well underground. And then moving forward to that, you then have your EV, bring it from the ground, obviously creating a chemical, putting it into your electric car, which then needs a motor to run, which then relies on getting electrons from wherever the electrons come from. And ideally, in a green future, there would be renewable sources such as solar or otherwise. Getting the electrons from that resource into your car so you can drive to the shop or to work, whatever it might be, requires a copper. And so it's all of these different metals and materials. And we just kind of bolster supply chain around all of those things. And also, again, decriminalize mining, because in the first instance, it comes from the ground or another resource, a natural resource. And in the future, when we have enough of that kind of metal or mineral in circulation, we can keep on recycling it. We become circular. But until you have enough metal in circulation, I think it's a bit of a pipe dream to assume that you can rely on what's already there to meet the current demand. We can't meet the current demand as is, never mind trying to recycle everything to meet that demand.
Absolutely. Tem, you're back from technical difficulties. This is your question. You are the one who actually called this out about energy transition versus metal transition. Actually, the day that article came out, our clean tech lead at TDK Ventures, Tina, she sent it to every one of us, and we all read the article, and we were all thinking about it. Why didn't we say it?
Yeah, absolutely. I wanted to write that because my colleagues in this industry are extremely passionate about delivering this energy transition, but many of them don't fully recognize that this entire energy transition actually hangs by a single thread. And this thread is the metals and mining sector. Stephen just talked about the mismatch between supply and demand of critical minerals, including battery metals. And that's a very, very real problem that this industry faces. And unless we address what's happening upstream, it's really hard to say, look, we're going to actually achieve all these goals that we have set out to achieve. I honestly think this energy transition is actually a metals transition. And going back to these commodities come from mines, existing mines. But I really like what's happening in this space right now, where new innovators coming in to disrupt classical mining with technologies like DLE to deliver additional sources of, for instance, lithium, hopefully all of us are working hard to reuse and recycle some of the mining waste that we have generated over many decades.
And it's amazing you say that. It is so exciting, all the things that are happening, but it seems like there's a stigma against mining. Can you just dispel some of the myths against mining just for the general audience? We'd like to hear more about different types of mining that is available. Some people who are talking about seabed, ocean floor mining, some people talking about clays and various other formats. Give us your perspective.
Yeah, I'll try. I appreciate you asking the question. There are many, many myths about the mining sector, right? It's very unlike of oil and gas, for instance. It is a very heterogeneous industry. We're talking about so many different commodities, right? And each one of them have very unique chemical qualities, characteristics, and then that demands very unique mining and extraction methods and technologies. You've touched on some of the novel ways to identify and find resources, but there are people who are looking at mining asteroids, for example. So I think this industry is quite diverse in that there are so many things that are happening. And I think that's one to realize. One thing I would also say is that it's a very sophisticated industry too. It has many years of experience and history. Many of the technologies that are still in use today are best innovations that we've seen over the last couple of decades. That doesn't mean, right, it can't be sustainable. Mining does have this legacy issue as far as leaving its waste behind, creating Superfund sites, creating environmental hazards, and so on. So because of the stigma, people don't want mines built anymore. But at the same time, people want to say, I want to buy a Tesla. So how do you achieve this goal of having hundreds of millions of Teslas on the road without having a mine in our own backyards? That's going to be a very challenging thing to accomplish. I'll just end with one quick statistic. I read this statistic a couple months ago that said that almost all of the battery metals and then the resources that are located around the world, or at least in the US, are actually located within 35-mile radius from a Native American reservation site. So if you think about nickel, cobalt, lithium, and graphite, many of these resources are located in very sensitive areas, right? So people don't want these things to be developed. So how do you then balance that is the big sort of a question I want to end on. Hopefully that'll spur some initial interesting thoughts and innovative ideas that can disrupt this space, which I'm here to invest in.
Let's double click on that. How do we do that? Because it seems like it has nothing to do with technology. It really has more to do with people's perceptions, sentiments, their belief systems. Who's to be the sort of the enforcer? Who should be the regulator of this?
I mean, to directly answer the question, it's for me, like I can't tell you who could be the regulator, but I was going to point out there are some technologies. So my company really is in existence to develop technologies to circumvent the mining process because it takes so long. We're on a mission to get lithium metal into a car as fast as possible, and it's challenging. So we have decided to go directly from oil field brine, think about E3 in Canada, direct to metal, and then pair it with a vanadium cathode, V2O5, or iron phosphate. So we'll have a lithium iron phosphate battery. It's LFP without the L, I like to call it. So we're looking at making next generation batteries come to market that just simply don't rely on the supply chain we have now. And if you pair lithium metal and vanadium, for example, you could have a North American based supply chain. It's possible. I don't know how to fix the mining. It's stigma in people's opinions. I just don't know how to do that. All I know is we're trying our best to get something completely different to market, and hopefully that will be helpful.
I think that stigma is slowly changing. I think what's happening in Silicon Valley and venture capital is that many investors are taking a closer look at new and novel mining technologies. Say 5 to 10 years ago, these same people may not have wanted to take an interest, whereas now they do. And I think the reason is because we just need so much of it that they're forced to take a closer look.
I would say that there could be some programs for consumer education or even understanding the needs of these could be potentially helpful. Maybe there's some IRA bill or something like that they could have introduced. I'm not sure.
I think it's a good point. And I think if you look at how to get from the ground to your battery, I think people need to understand that whole flow. And in terms of innovation, we should also understand that if you look at the origin, a lot of these kind of chemical processes or otherwise, right, mining and then the further on process plant. I mean, back in the olden days, the guys were more concerned about how can you make this as cheap as possible. there wasn't really much thought in terms of the environmental credentials or sustainability of the process. And I guess leaning into that, we're trying to get to an electric future, and this kind of supports this electric revolution because it's cleaner and greener, right? We want to have a green, clean world for our kids one day. And so in terms of the technologies that we're using to get there, we should also try and innovate and make those as clean, green, cheap, and sustainable as possible. And so I think both in the mining piece, getting the stuff out the ground, but then when you have a mineral to then remove the lithium or whatever it might be, the chemical process, which, to be honest, currently they're still pretty dirty. If you look at good old-fashioned hydrometallurgy, they're using strong acids to strip out the lithium to lithium sulfate, a number of additional processing steps to then get your lithium chemical, say lithium hydroxide, lithium carbonate. But there's a number of new technologies out there which are looking into better ways of doing that. Novolith is investigating one of those, where we're directly using carbon dioxide as a direct lithium extraction, where we strip it out of the resource directly as a lithium carbonate. And because we're not using strong acids, we get around a number of those environmental concerns. Right? You get your sulfur, what happens to your sulfated byproducts or otherwise? Moving forward, we should really be focusing on how can we do things better, and not just with Novolith's technology, but all these burgeoning technologies out there. There's a lot of really cool clean tech, deep tech startups out there. So just give them as much support as possible and try and fix this massive supply chain issue. Because even if you can get the mines up and running quick enough, which A, is a problem, B, you're going to have all of this material to process, but then, hey, how are you going to process it? And so two big problems to solve there to really get to that third point of pumping out cheap green EVs.
Absolutely. Talking about innovation, I want to slowly get into that side, because what types of innovations are we seeing in extraction or pulling out of lithium in brines, hard rocks, and clays nowadays that are making many of the big mining companies explore these new technologies? Stephen, I think you jumped the gun on this, but Stephen, Emily, feel free to chime in, because I think the partnership is important between the miners and the startups, or maybe even oil companies and startups. So maybe elaborate a little bit on that.
Sure. I'm happy to. I think to your point, my biggest investor is a miner, Robert Friedland. He's one of the most successful miners on the planet, and he does things very differently. What I have learned from him in this past amazing year of working with him is the actual positive impact that you can have on communities all over the world when you build these mines if you do it correctly. And it's actually really inspiring. I would like to see him recreate some of the things he's done in the DRC right here in America. We're looking to lead by example, but I think that the mining companies, and they all approach me, they're all interested in new technology. I really see the mining companies starting to work with innovators like myself, and I've been watching it happen for the last couple of years. So I think it's really exciting that we are coming together.
Maybe we could just move towards some of the extraction and other innovations that are happening in taking lithium out of some of the recycled feedstock as well, just from the LFP's dominance that's happening today. It seems like LFP chemistry is going to be ubiquitous. The NMC is not going to disappear, but certainly LFP is coming up. Does someone want to chime in here on pulling lithium out of black mass or other recycled sources, especially for LFP?
Okay, maybe I can start with and inspire the team. So I think definitely lithium extraction is very important for lithium iron phosphate. Think about right now, we have around 40% cathode belong to lithium iron phosphates, and will continue increase to 42%. I think this is a little bit conservative to 2030s to get the lithium iron phosphate recycled and get the lithium out of that. I think we need some disruptive technology of that. I think we, as a recycling company, we are working on that, but the whole industry, I don't see we have reached there yet. For the NMC type of batteries, I think we are slowly getting there. Currently, we can claim we get 80% lithium recovery from that chemistry. Lithium iron phosphate, we try all kinds of methods. So a lot of new industry get involved in this.
And Haisha, what's the major bottleneck there? Why is it only 80%? We're now so used to recycling technologies returning 95, 98%. Why are we stuck at 80%?
Because sometimes we need to make this lithium reusable. We try to make a battery grade lithium carbonate. In that case, we say 80%.
I see. Stephen, your thoughts on this?
Yeah, that's actually really interesting. And the battery specs are getting stricter and stricter and stricter. So that's going to have a downward knock-on effect on the recycling and the lithium recoveries from recycling. But then also, again, on the extraction tech, from the ground. And if you look at, I guess, kind of the swathe of resources out there, from brines to micas, spodumenes, whatever they might be, the innovative tech in each of those, and DLE is being very complicated in terms of the chemistry set, not one size fits all. And for your rocks, you're very much the same, but relying on the conventional or kind of old school tech with the incumbents. So that the innovation moving forward is really not much out there, especially for hard rocks that'll get you pretty much straight to your battery grade, which is really interesting. And looking forward in terms of even the recycling side is still relying on the old school hydromet. So finding technology which could also then be cleaner and greener for both recycling would be great. Now that there's a real kind of wave that we're all riding on, is this kind of lithium wave, I think with all of the new investment, all the really smart people working on this, I think there'll be a lot of interesting solutions to come up in the next couple of years. But whether we get there fast enough is the next question.
Yeah, absolutely. And I mean, let's not just talk about cathodes here, but we have to talk about anodes as well. What about graphite? Graphite is a form of carbon, right? Ultimately, you have to get it from somewhere. Are there nice, better, sustainable ways people are able to get graphite from? Are the synthetic graphite companies doing well? Give our audience a flavor of what kinds of innovation that you guys are seeing on graphite and maybe even silicon, right? Because it seems like that's the next wave.
Yeah, I think lithium metal anodes are the next wave, so you probably don't want me to go first.
You should.
Look, graphite's great. Lithium-ion battery has gotten us so far. It's amazing, but it's 1 lithium per 6 carbons. So the energy density, it just isn't there. If you go to a thin, pure lithium metal electrode and an unlithiated positive electrode, so no NMC, nothing that has lithium in it, so you actually can use all that capacity. You have 3,800 milliamp hours per gram of energy in a lithium metal anode. You've got 372 in graphite. So if we really want to see these jumps, you can make large format cells with lithium metal. Lithium metal is not synonymous with solid state. There are a lot of reasons to really be bullish about lithium metal, especially if it can be made really cheaply and efficiently at scale.
Emily, to double click there, are lithium metal anodes coming at a very high purity levels? I heard Joe mentioning that, hey, there's not enough very high purity lithium metal.
Yeah, so
What's
the
your take on
last decade of my life has been looking at this on a micro level. We buy everybody's lithium metal, analyze the thickness. The impurity profile is insane. It's insane. And we worked very closely with our ICP manufacturer. We have a standard for the 2 isotopes of lithium because we are aspiring for the highest purity lithium. Anything in there, any anomaly, any difference in the thickness, so the tolerance, it has to be very, very, very even. The specs for lithium metal are incredibly challenging, but when you get it right, the cell performance, it's incredibly different. The extruded ingot foil method, they're not sufficient for next generation rechargeable batteries. Nobody makes a lithium metal electrode. It just doesn't work. You can't ship it, handle it. And then you take this ingot and you foil and you smush it onto a piece of copper and you have massive impedance. So it's really challenging. The specs are, as Joe said, to his point, they're just getting more and more and more challenging. But when you get it right, you have this beautiful cell that cycles amazingly well, and you get to the large format. You can have 100 single cells in a car, not 7,000 with lithium ion. So the benefits, the rewards of doing this hard work, we have to do it.
Emily, help us understand a little more on the supply chain of that.
So my busy, when I started, I just wanted to take what Joe will call off-spec lithium carbonate and use it as a precursor for our ambient process to make metal. We use a polymer membrane, we put on a piece of copper, and there's a whole bunch of secret sauce in this, but it's really pretty simple electrochemistry, electrodeposition. It's just membrane assisted. And that membrane then becomes a solid state separator in a battery, which is really cool and cheap way to do it. But the thing that's, so important about the supply chain is that lithium ion, everybody wants it today, right? It's not online. There's a huge shortage. Look what the market has done. SQM became the biggest company by market cap in Chile because of the price and demand at the same time of lithium. It's crazy what's going on. There is no supply. So I had this vision, we get this off spec, and then China has brought on all of this refining online. There isn't the supply of it. So we have to look deeper. We look to lithium sulfate, and which is great. We can use that. We have a partnership with E3 Metals in Canada, and they're working on their DLE process, and we can take their material right now and make electrodes at a really good cost. So when we work with these partnerships, hopefully a lot of things can happen, because right now there just isn't a supply chain. And for lithium metal, These numbers are a couple months old, but it's 1% of the market. Chloride is the precursor. That's 3% of the market, and we need it for everything else. So there's no supply chain for lithium metal now. So when GM makes these announcements that they're going to have lithium metal in all their cars, you're just wondering why the SEC isn't ringing their doorbell, because there is not enough lithium out there to make this. And there isn't enough to supply for lithium metal batteries. We really have to reinvent the whole supply chain. And I'm so thankful that I have a miner for an investor, because he understands how long these projects take and patient dollars. My company basically straddles mining. It's a mining and technology company. So it's really important. We have to build this whole supply chain.
Well, thank you so much for enlightening us about this. Talking about patient capital, can everyone please discuss the value of patient capital? Because it seems like that is needed in this industry.
I think in terms of patient capital, it's a really good point. It's not quite software, right? Doing deep tech, climate tech, it takes a long time. It generally takes a lot of money. And it's not something which is an overnight success. And so I think for any investors looking into the space, you're not going to get a 12-month unicorn, right? It takes years and years and years to prove up your technology, take it from lab to pilot, make sure that you've ironed out all the bugs, understand how everything works, then go to commercial demonstration plant, get industry comfortable with what you're doing. Because again, if you're looking at, say, the miners, the OEMs, the vehicle manufacturers, etc., they need to see, feel, touch at a commercially representative scale. And off the back end of that, then you can commercialize your technology and start pumping out commercial process plants. And this is not a 1 or 2 year thing. It's a 5 to 10 year journey. And again, very capital intensive and relatively high risk of software. If something goes wrong, you can't just change a line of code. You have to go back to the drawing board, buy some new equipment, which has lead time. And post-COVID, we're still struggling with supply chain delays on a number of different equipment items. And so these are things which are going to become challenging moving forward, and I think already challenging.
Gotcha. And from the perspective of how long is long, I think that's another question that people would want to understand. The reason why I ask is because traditionally you have VC firms, and then you have PE firms, right? And then there's project finance. It seems like the VC firms are very small, right? Often like ours, 150, 200 million style, right? And then you have other firms that are very, very large, billion plus, or maybe 10 billion. It seems like there's very few in the middle who really can kind of power this through. So is there a sort of a capital allocation gap there?
I can try to chime in. Hopefully my network can sustain my energy here. So I actually used to work for a private equity fund called Resource Capital Funds, and this was a $4 billion fund platform with multiple strategies. And what we did mostly was project finance. We actually financed lithium companies, financed copper projects, built these things. And oftentimes, even having a $2 billion fund, it's not big enough, right? Because these things actually take billions of dollars. So the capex of these projects are incredibly huge, very capital intensive. As Stephen was talking, it takes forever to build these things. And then you come into situations where you don't finish the project on time. It's typically over budget. I think you do have to have that patient capital mentality. Sometimes projects actually take longer than the duration of the fund that the initial investment was made in. And it actually forces companies, private equity firms, to exit prematurely, which is very unfortunate. But I think what's happening is more and more people are realizing that it actually takes more time, and they're structuring their funds as a 15-year fund instead of 10 years so that they can actually continue to wait and really reap the benefits of providing that risk tolerant capital early on. Now, venture is a very different ballgame, right? VC firms are investing in technologies that are truly game-changing and betting on things that would completely disrupt. They're happy taking a longer view, but with the understanding that they're not going to provide hundreds of millions, if not billions of dollars. So I think the strategies are very different. But I think what's happening with this recent sort of attention to the spaces is that more governments, at least the US government, is taking a closer look at what's happening in this space, trying to bring back domestic supply of critical minerals and trying to deploy capital through the loan programs office. But I think that's a great example of the government initiating a policy to fill in the gap.
Thank you, Tim.
I can help complement Tim's comments. I think common sense take at least 10 years longer time to build a mines and make it functional in a good way with good yield. I'm doing recycling, so I'm trying to talk mine here. But recycling, actually, everything is quite pure. When you go to a battery, it's quite pure already. So just a few elements there. So you take a lot less time. I think Ascent Elements will get funded from 2017. Right now, it's just 5 years. I think the technology is in a good develop. I would not brag it, but I think in a good shape. So yes, I totally agree. The capital investment in this area is very intensive. So that's why we trying to avoid the whole industry trying to avoid manufacturing in Western country. And we would like to finance good ideas, but actually those good ideas take a very long time. So if any ask how long time for the investment return, it may take forever. But I think currently for the lithium battery industry, recycling is a good way to go because the technology is there. For the bigger manufacturing, about the cathode, the readiness is quite high.
Harsha, given the topic of recycling, people are talking about closed loop recycling nowadays. Can you explain what that is?
Yes, closed recycling is very crucial. So everybody talk about supply chain security. So recycling as well. So first of all, we want to make sure we have enough black mass, and then we can feed the cathode and the anode. That's number one. The second is the price in the market of all the metals fluctuate a lot. So if Emily give me some battery scraps or used batteries, we're going to process it. So we are secure, independent in the market fluctuation. So yeah, we are all in a good stand in this case.
Very cool. Maybe one last question to each one of you. What is one question that you wished I asked? Emily first.
What do you think the number one contribution that everyone on this panel can make to the metal transition? I'm going to use Tim's phrase.
Yeah, that's actually a great question. And I think in terms of everyone on the panel, we each kind of bring our own skill sets. And if you're looking at the technology backing us and where we fit into that supply chain, I think that's super interesting because at the early stage, especially with what Nolith is doing, we're looking to find better ways of getting lithium from the ground into circulation to then either as lithium carbonate or ideally as lithium metal long term, just so we can get to the point of that kind of closed loop recycling and trying to get as much black mass out there as quickly as possible. And going back to what Tim was saying earlier in terms of the capital intensity and timelines, mining is not cheap. A ton of money going to the mine. Once you have your mine defined, then you have the downstream processing, which again is not cheap. And depending on the technology innovations there, the more cost effective you can make that second step, I guess the more you can leverage that front end in terms of your mine and work with, say, a lower quality resource or different resources, which again, Emily, is what you're looking at the moment as well, to try and circumvent the current limitations. I think a lot of emphasis needs to be put on that now to get to the point to begin that closed loop in, say, 10 or 15 years' time.
Very interesting. Thank you for that. Tim, what do you think? What is one question that you wanted me to ask you that I didn't ask?
I think maybe talking about the other metals, I think lithium gets plenty attention. There are many other. Lithium is just one of the many examples. I think there are other critical minerals that deserve equal attention, especially when it comes to building motors that require fancy magnets that use very advanced elements. I think that would have been helpful again, but that's my biased view from a mining perspective.
Can you elaborate on those?
Yeah, happy to. This recent legislation, didn't read the entire text, but if you do a quick skim through it, you'll find that it talks a lot about the importance of having or securing a domestic supply of critical minerals. And what does that mean? What is even critical mineral, right? What element qualifies as a critical mineral? It goes really down deep right into this whole discussion. But if you just take, for instance, rare earth elements, for example, I think the United States, I think its reliance on refined rare earth elements is almost 100% on Chinese production. And that's a very sensitive topic that people don't want to talk about because we're all pushing forward and pushing all these technologies to be developed, but then understanding that there's just really one country that actually controls the entire supply. I think that's a key example. And obviously rare earth isn't the only one. There are many other cases like that. So I think while we're very euphoric and happy about some of these headline news that we're seeing, I think we need to have more decisive deregulation taking place in mining, especially in the US, to ensure that we can supply these critical minerals locally. Going back to the timelines we talked about, it's incredibly hard to permit these mines. So unless we make it very easy, remove some of the barriers around regulation, this bill isn't going to have any impact on what's happening in the mining of these critical minerals.
Perfect. And Haisha?
I can help to add some good comments to Tam. I totally agree. The regulation in the government actually is the most time consuming for us to get a permit. So I totally agree with that. For the mining industry, I think is very classic and traditional way to think about how to get those metals other than lithium and cobalt. To replace this game, think about it, in 2025, we have a 250,000 vehicle in the car. And right now, everybody have a few more at home. We don't think a few years later, we have a few cars at home and put the battery in a garage. So we have to figure out a way to recycle them. So recycling is another way of mining. That's maybe the main reason Anil put me here. So trying to remind from those blackmails. So yeah, totally agree on the government regulation. And also we change our mindset. Not just change some money, maybe money from our current commenting.
Perfect. Well, I could go on and on for another 2 hours on questions. Unfortunately, we do have limited time here. This has been really fun, fascinating session. And sincere thanks for all the panelists for their views. I did run a quick LinkedIn poll from my network recently on this particular topic. I asked the question, what do you think as most needed to build a full battery supply and recycling ecosystem in the US? And I actually got some really interesting results. The conundrum here was 1 and 2. I mentioned we need more capital to build capacity because without capacity, nobody will give you feedstock. And the second one was speedy access. So anything that makes you go faster instead of waiting for 10 years or waiting for 2 years in a pond for the pond to evaporate. It seems like a very low tech way of getting lithium out. So there was a very strong push and pull between 1 and 2. And finally, it seemed more capital came out to be a winner in this. But of course, there were other 2 options as well. One was regulating recycled materials. Seemed like getting hold of a better ecosystem, because if you regulate them, then you have to recycle the manufacturing scrap. You have to think about all the way through, right from production all the way to even when the EVs are no longer useful. And the last one was local raw material access. This is a little difficult one because some countries don't have access to such rich resources like the South American Triangle or Australian green bushes or something like that. But certainly there are places that we could be exploring more. Even within the United States, there seems to be more activity going on. That came out as a number 4. Maybe I'll get the quick pulse from the panel. What you think of this poll? By the way, this is just from my LinkedIn network. It's not like a very organized thing or anything like that.
I was going to say, I think there should be the 5th option of all of the above. I think it requires all hands on deck. I think solving for climate change is a group project. I think it requires everybody to have a hand in it. I think it requires a lot of capital to go into it. It requires making existing mines to be more productive and efficient while we're pushing for new technologies that would reinvent how things are mined. And then we're dealing with the mining waste. I'll just leave you guys with one statistic. The mining industry generates 72 billion tons of waste every single year, right? There's so much value within that. So instead of focusing on mining, can we also at the same time focus on reusing and recycling that waste, which I think is actually a value.
Thank you so much, Tam. And you added option 5. So actually, we have invested a lot of capital to the industry of lithium battery related. But this capital, I think, haven't got a good favor on the manufacturing part. So we invest a lot of disruptive technology, but solid state can be manufactured, but not that yet. But it's those kind of example. If we can invest more on the manufacturing parts, then it will really helpful. And maybe option 6, in addition to TAMS. So I think we do need a lot of engineers. We do need a lot of skilled workers. So when I talk to my colleagues, they say their class in the college started with 40 or 100 people. in the first year, and then in the fourth year, they got a 4 to 10 graduate from chemical engineer. So I don't think as a society, if we can success, it's going to be huge, and we will bring more young generations to the industry.
Thank you very much for that. Perhaps we should go to audience questions and have Emily and Stephen take a stab at the first two. It comes from Victor. Is a decentralized supply chain advantageous, not only because of local supplies, but because of transportation costs?
Absolutely, 100%. Transportation costs are tragic, just a tragic layer to add on to an already low margin product, which is called a battery. So absolutely anything that we can do to take price and CO2 out of the equation, we need to do. And if we're not mindful about it either, we're happy to take a lithium atom and fly it 55,000 miles around the globe from it gets the ground into your device. We just don't even pay any attention. There are companies shipping brine and aqueous. It's huge amounts of money we go into shipping. And the problem with shipping lithium metal and lithium products, they have very low shelf life. So the closer we can make and more vertically integrated we can be, the better off we're all going to be.
Thank you, Emily. Let's bring up the second question. What are some of the most important things we can do to decarbonize the lithium-ion battery supply chain? Good question. And it comes from Andrew, my colleague.
So I think in terms of this one, going back to that first point, decentralizing the supply chain would be a great way of decarbonizing. To quote, I can't remember the gentleman's name, but I was at a conference last week. Apparently it's 100,000 kilometers from mine, production, etc., before it gets into your EV. So that's the distance your lithium metal travels before you actually get to use it as an electric vehicle, which is an obscene number if you think about it. Never mind the CO2 associated with transporting that. And if you're looking at raw materials in terms of the lithium concentration, you're supporting, say, lithium concentrate at 4% lithium oxide, 6% lithium oxide, versus either a lithium metal, which is 100% lithium. If you're doing that locally, the amount of CO2 you'd negate just by localizing your supply chain is tremendous. Plus, obviously, the cost benefits associated with that. So I think that'd be the biggest one. And then second to that, if you're looking at your scope 1, 2, and 3 emissions, finding newer technologies which have much less of a CO2 footprint, right? So if you look at all the reagents used in conventional processes, generally they have a lot of CO2 associated with the production of those. The energy then in using producing those reagents, et cetera, et cetera. So finding lower CO2 methods of producing lithium chemicals would be another great way. You couple that with decentralized supply, and I think you're on a really good path to decarbonize battery materials in general.
Perfect. Let's bring up the next question. This question comes from Catherine, my colleague again. Panelists, building supply chain in the US takes time and also hard to achieve the same level of low-cost batteries that are produced in China. What do you see as strategies and what are the opportunities for startups? Good question.
Agree. I think building supply chain is definitely not a short project. So let's say back to the first question, we talk about the globalization. So actually the technology there are a lot of things, the technical readiness is there. So sometimes we have to learn from others. So take a good advantage of those. So in parallel, we have our own innovative method, but at the same time, we have to learn from others.
Thank you. Let's go to the next question, please. Should there be more incentives about sustainable mining, like Stephen and Tim mentioned? Sustainable mining and just mining should not be mutually exclusive, right?
I agree, but I'm not sure what kind of incentives this individual is thinking about. I do like incentives, but we can't take certain things out of our one pocket and put it into our own other pockets. I think we gotta incentivize innovation correctly. When I think about the mine of the future, it's not about building mines the same way, or maybe do it slightly better, or maybe do it slightly more productive. That's not what I'm thinking about. I'm thinking, going back to what we just discussed about the decentralized supply chain, I think that's really interesting because that includes the mine itself. So instead of mining things through open pitting or whatever method you choose, but can we actually completely rethink how we actually mine that or have that activity? Can we have something that's more modular, more flexible, more adaptable, that doesn't generate any waste, that doesn't require a surface area or footprint, or doesn't affect the nearby communities or the environments, right? So I think that's how we got to think about it. I think we got to really think about what is the future of the mine and then have this white canvas to work off of, and then hopefully provide some incentives, whether that's funding or having programs or investing in the mining schools to prepare the next generation of engineers. Do all those things together in concert to then disrupt this entire sector, right? I think that's what it's going to take, and that's a very challenging task, but I think that's my view.
Thank you, Tim. Let's take the next question. Oh, this question is for Emily. Can she expand a bit more on her comment on designing different batteries for India market, which don't need to survive at negative degrees Celsius temperatures? I'm not sure. India also has very cold temperatures.
Yes, they do, but geographically, you think there are some regions where it doesn't get below freezing for sure. There's some large swaths of India that are not going to get below freezing. So if you're thinking about making batteries as a rank beginner, one of the easiest things to do is make a medical implantable battery, because the operating window of the human body is very narrow. We get so cold, we freeze. We get hot, we burn. So the design parameters, if you're designing a battery and it doesn't need to work in the freezing cold and work when it's 120 degrees, it becomes a lot easier. So my point is that if we really start thinking geographically, we have Professor Sadoway's actually invented 2 astronomically beautiful batteries for India using non-flammable molten salt. That would just be phenomenal for the 2 and the 3 wheel market. And when I started Pure Lithium, we did it to make an impact, a really big impact. So we look at geographical areas in which deploying technology could be impactful. So I think if we just start to look at the whole problem, like everyone on this panel has said, this is a big group project, and just start to shift the paradigm and think differently, we will all make a lot of progress together.
Well, I think that those are great words. Thank you, Emily, and thank you all panelists. I have just 1 minute to wrap up here. And for all of you who joined during the session, sincere thanks for taking the time to participate. We at TDK Ventures always share our learnings openly. You are welcome to view these videos. They're all going to be available to the public. And sincere thanks to all our viewers, panelists, and supporters, and our partners. We really want to thank every partner of ours, both on the VC firm side, also on the industry partner side, and also on the research student club side. Sincere thanks for partnering with us. And also we want to give a shout out to some of the startups that were here. Emily's startup, Pure Lithium. We want to give a shout out to our portfolio company, Ascend Elements, and many others who are doing extremely well and supporting the energy transition here. This concludes our Energy Week 2022 online event. Here I am representing our entire TDK Ventures team to thank you again for your participation at Energy Week. We welcome you to really follow us on all our social media channels, scan the QR code, and you're welcome to reach to us on LinkedIn. We will see you again next year. Thank you.